Hello, welcome guys. Today we are going to this is lecture 2 and we are going to start from path length. So, consider the motion of a car along a straight line. We choose x-axis such that it's coordinate with the path of the car of motion and origin as axis from the point where the car started moving. That is the car was at x equal to 0 at t equal to 0. Let PQR represent the position of the car at different instant of time. Consider two cases of motion. In the first case, the car moves from O to P. Then the distance moved by the car is OP equal to plus 360 meter. This distance is called the path length traversed by the car. In the second case, the car moves from O to P and then moves back from P to Q. During this course of motion, the path length traversed is OP plus PQ equal to 360 meter plus 120 meter equal to 480 meter. Path length is scalar quantity, a quantity that has magnitude and no direction. So what this means that path length is scalar. What is opposite of scalar? Scalar opposite is vector. Vector has both magnitude and direction, right? Displacement. So now in this whole scenario, what he's telling that the path length is it doesn't matter which direction the car takes. Only the path length gives us the distance traveled by the car. Like if it goes about 280 meter over here, then for again it goes up to 400 meter, and it takes a U-turn and comes back to this minus 60. So while taking displacement, we will be considering it as minus 60. But while considering about distance, we are going to take it as plus 60. Because this distance does not care about the where the body is going. It just cares about how much distance it covers. Is what now displacement. Displacement is irrespective of the path length followed by the car. Alright. But the path length depends on the path length followed by the car. Displacement is the shortest distance. It is useful to define another quantity displacement as a change in position. Let x1 x2 be positions of an object at time t1 and t2. Then its displacement is denoted by delta x in time delta t. T2 minus t1 is the given by the difference between the final and initial position. Delta x is given by x2 minus x1. What he's telling is that the this delta shows difference. What is the difference? What was the initial position and what was the final position? So final position minus initial position gives you the what do you call difference between the final position and initial position is represented by delta x. Look, we use the Greek letter delta to denote change in quantity. If x2 is greater than x1, delta x is positive, and if x2 is less than x1, then delta x is negative. Displacement has both magnitude and direction. Such quantities are represented by vectors. So displacement is a vector quantity because it has both magnitude and direction. Right. Now, you will read about vectors in the next chapter. Presently, we are dealing with the motion along a straight line, also called rectilinear motion. In one-dimensional motion, there are only two directions, backwards and forwards, in which the object can move. In these two directions, the direction can be easily be specified as plus and negative signs. For example, displacement of a car from O to P is x2 minus x1. So what he's saying now, O to P, right? He's asking the what is the displacement. So this P is nothing but x2. P is nothing but x2. And O, the position at O is x1. So x2 minus x1 is nothing but it will give you the displacement or delta x, right? So this is 360 minus 0 is nothing but plus 360. This is equal to delta x. The displacement has magnitude of 360 meter and is directed in positive x direction as indicated by the plus sign. Similarly, displacement of the car from O to from P to Q is 240 minus 360 equal to minus 20. Now what happens here? Why there's a negative symbol? Because of displacement cares about the where the body is moving, right? It cares about in which direction it is moving. But whereas displacement don't take care of about that in which direction body is moving. From P to Q it is going backward, and we have taken as a what do you call convention that we will take left side as negative and right side as positive. But from in this case, from P to Q it is moving from positive to negative. So what is the final position? Final position is nothing but 240, and initial position is nothing but 360 meter. So here the x2 is less than x1, therefore the displacement will be negative. Let us go forward. The negative sign indicates the direction of displacement. Thus, it is not necessary to use vector notation for discussing motion of objects in one dimension. Yes. So, vector notations are not. It comes into use in when we talk about what do you call? Two dimensions. Two dimensions mean when we have two Cartesian plane, x and y plane. This is y coordinate, this is x coordinate. So he in this case you can't take like a positive down, we take a positive and down negative, but we cannot use, we need some additional quantity to represent that where the body is moving. Is it moving on the x axis or y axis? When we come to three dimension, then it even z axis also comes. This is x, this is y, this is z. So z axis is nothing but it is called vertically upwards or vertically downwards, right? Now, the magnitude of displacement may or may not be equal to the path length transverse by the object. Means path length transverse by the object means path length covered by the object. So, what is displacement? Displacement has a condition. If s is we represent s as displacement and t as distance, then it must be less than distance, or up to maximum it can be equal to distance. But it can never, displacement can never be greater than distance, right? It can be equal but it can never be greater, right? For example, motion of a car from O to P, the path length is plus 360 meter and the displacement is 3 plus 360 meter. In this case, the magnitude of displacement is 360 meter is equal to the path length 360 meter. But consider the motion of a car from O to P and back to Q. In this case, the path length equal to 360 plus 120 equal to 480. However, the displacement is 240 minus 0 equal to 240 meter. Means like in this case what is happening, it is the body is going from O to P and it is coming back to Q. Once again I'll just erase it, it become easy for me to explain you. Use a different color. I'll use blue. Like what he's saying, the body is going from O to P and back to Q, right? So the body is going from O to Q, O to P and back to Q. So the distance traveled is nothing but 360 plus this distance, which is 120 meter. So this is the total distance, but displacement is only this part, this 240 part, right? Let's move forward. Thus the magnitude of displacement is plus 240 meter and is not equal to the path length 480 meter. The magnitude of displacement of for a course of motion may be 0, but corresponding path is not 0. For example, car starts from O goes to P. So now what he is telling, displacement can be 0, but path length can never be 0. Right? It can only be 0 when the car does not move itself. Like if you keep a body at rest and you say the distance is 0, of course it is 0 because it is not moving. So now let us come to, however it returns to P, the final position coincides with initial position. Now what is telling, when the final position coincides with the initial position, then the displacement is 0. Then the displacement becomes 0. However, the path length from OP plus PO equal to 360 plus 360, which is 720. Like if your school is 3 kilometer far, if you go from your home to school 3 kilometer and come back to your home, then the displacement will be zero, but your path length covered will be 6 kilometer. Motion of an object can be represented by position time graph, as you have already learned about it. Such a graph is a powerful tool to represent and analyze different aspects of motion of an object. For motion along a straight line, say x-axis, the only x coordinate varies with time, and we have xt graph. So when we make a graph, xt graph is also called position time graph. Like it represents how much the position changes with respect to time. Like if this is the graph, then we can call this a body is at rest, because the body is not at all moving. But when it is going like this, means body is in uniform motion. If it was to be going like this, then it is at motion but not uniform. But when it is a straight line, it is in uniform motion. Along the straight line shows position time graph. Let us first consider a simple case which is object is at stationary. Look, it is at stationary. Example is car is standing still at x equal to 40 meter. The position time graph of a straight line is parallel to the time x-axis. If an object moving along a straight line covers equal distances in equal intervals of time, it is said to have non-uniform motion along a straight line. Shows the position of a graph such a motion. This is the position time graph. This is non-uniform moving body, a body moving with non-uniform velocity. If a body is moving with uniform velocity, then you know how the graph is xt graph. You might be thinking that it is going to be a straight line. No, you are wrong. It will never be a straight line if the body is moving with uniform accelerated motion. If it is moving with a uniform velocity, then it will be a straight line. But when the body is moving with uniform accelerated motion, means with some what do you call, with some acceleration, uniform acceleration, then the graph will be like this. Oh, sorry. Your graph will be going like this. It will be a kind of an exponential graph, right? Now let us consider the motion of a car that starts from rest at t equal to 0 from the origin O, picks up speed till 10 equal to 0, t equal to 10, and thereafter moves with uniform speed till t equal to 18, then brakes and applies brake and stops at t equal to 20 second, x equal to 296 meter. The position time graph for this case is shown in figure 3.3. We shall refer to this graph in our discussion of the following section. Now this 3.3 graph, this is a 3.3 graph. This represents this graph represents the motion of a body. This is the condition. This is the proper condition for this graph, right? So average velocity and average speed will be covered in the next lecture. Bye. Let us see you in the third lecture. Bye guys. Wait. Hey, डब्बा बन जा रही, बन जा. Bye.